Now, we, as Ron said at the very beginning, um, the cost of capital platform that we have here, and I'm the author there, and I designed it, and I designed it in a certain way. And one key way is to make it straightforward, because making it complicated and making it and over engineering it, it just is not helpful to you guys as practitioners. What I did not want to do is to create a cost of capital platform that is a Rube Goldberg contraption. And for the younger folks here on the web seminar, if you don't know who Rube Goldberg is, look him up. He's up on Wikipedia. He's a guy that lived uh, several decades ago, and he would make cartoons. He's an engineer as well as a cartoonist. He would draw uh, contraptions, gadgets that did simple tasks but make them very complicated, and they were quite entertaining. When I designed the cost of capital professional with the help of BVR to do the engineering and all the hard stuff on the back end, I did not want to make a Rube Goldberg, and that's the first attribute that Ron mentioned as being straightforward. So, in understanding value can be reduced to this is a very simple reduction into a firm's income divided by the risk minus the growth, and that's the dividend discount model. If you don't know what it is, and then more technically, what you see at the bottom, the value of a firm is its free cash flow divided by its cost of capital minus its growth in the free cash flows. Okay, all that's well and good. It sounds very simple, and in theory it is, but in practice, getting the inputs for this clean looking formula, that's the hard part, and that's where you are for practice. Ron, any thoughts?
Mike, I just mentioned that this is a schematic that I've used a few times in testimony, where I have to explain the income approach to value to a judge or a jury. And all we're talking about today essentially is the R of I divided by R minus G. And the devil's in the details. We could have a whole part two to this and talk about how you define the free cash flow or the income part of this formula. But this is just kind of something to help articulate and explain cost of capital and how it works in calculating value to folks that aren't as deep into it as our listeners are today.
So in reality, when you have something that's complex, often the best answer to a complex phenomena is the simplest answer. And conceptually, that's called Occam's razor. Occam's razor, and you may remember that from somewhere in your past. And it's also called the principle of parsimony. So, in what I tried to design here on cost of capital professional is try to reduce things to be relatively simple. Now, it's not simple, but it's relatively simple. Making things more complex is not necessarily the answer. It might be the answer in physics when you try to launch a rocket from Florida and you have to get into the precisely hit orbit in Jupiter 8 years later. That's governed by the laws of physics, and maybe that is rocket science, literally. But when you talk about cost of equity and cost of debt and so forth, there is no laws of physics. So try to make it simpler. And if you are doing cost of capital and you're taking it out to 5 decimal places, it appears to be scientific, but really it's probably creating more noise than's justified, and is distracting. And although it gives the illusion of precision, it's not. It's probably not more precise by trying to make it go out to X number of decibels.